Today we're going to be making XLR audio cables. XLR cables are easy to make even if you have basic soldering skills. It's a useful skill to have since it's cheaper to make and repair your own cables than just buying them at the store. Here we have the W2552 balanced mic cable. It's fairly thin, so it's not good for field use, but it's perfect for install or bag use. It has a spiral shield which makes it easier to terminate than something like the Canare L4E6S, which has a braided shield. This cable is 41 cents a foot from Redco Audio, so it's a pretty inexpensive cable. Next you need connectors. These are the Amphenol AC3F and AC3M. The 3 is for 3-pin, and the F and M are for female and male. The AC3F is $1.79, and the AC3M is $1.50 from Redco. The female and male components are fairly similar. They both have this connector boot, which screws on the back. Next is a strain relief that goes inside the connector body. Then the shell, this is the male one, and this is the female one. Then are the inserts. This is the female insert, still inside the shell. And this is the male insert. First part of prepping the cable is cutting it to length. For this project I'm making a 5-foot cable. This right here is 5 feet. I'm going to add a couple inches to it for the connectors because you'll lose about 3/4 of an inch to an inch per connector. The most important part of the cable prep is to remember to put all the stuff on the cable before you start soldering. For these Amphenol connectors, you need to install the boot and the strain relief first. Once you prep the ends, you'll put the connector on and slide the shell over that. If you forget something on the first, and you can thread it on from the opposite end, but once you solder both ends, you'll have to unsolder one to put anything else on. To strip these, you can get a stripper designed for coax or larger diameter cables, or a thermal stripper perhaps. I prefer to just use wire cutters. These are Klein wire cutters. They're curved, so you don't squish your cables if you're cutting round cables like XLR coax cables. With a gentle touch, you can cut through only the outside insulation of this wire. There we go. Now you can see what I meant by this having a spiral shield. The shield is wrapped in the center conductors. It's not braided or anything. So to separate the two center conductors from the shield is pretty easy. You just twist the shield together. Now you have two conductors, the positive and negative, and the shield for ground. Next we'll strip these, tin them, and then do the same thing for the other end. There we go, ready to be tinned. Another tool I really like is this set of helping hands. It's a set of alligator clips on articulating arms. It's really nice because it can hold small wires or components. Once the iron is hot, we can start tinning our wires. Tinning, if you don't know, means to put a little bit of solder on the wires. This helps to stick the wire and the pin together since you don't have to add any solder later. It's called tinning because solder is made of mostly tin. After building many cables, I decided to make this jig, which is just 2 panel mount XLR connectors, one male, one female, mounted to this piece of wood, which I can clamp in my pan of ice. I can just take these connectors, stick them in the panel mounts, and I can solder them without having to clamp each one individually. Now we're going to tin these solder cups. They don't need to be tinned heavily, we're not putting massive wires into them. Tin the tip of your iron first to get good conductivity. Then I just put some solder at the back of the cup. That's all that's really necessary. You don't have to fill the entire thing with solder unless you're doing massive amounts of wires or very large wires. I've zoomed you in here so you can see the connectors. These connectors have numbers molded into the plastic. Most good quality connectors have these numbers, Neutrik, Switchcraft, and these Amphenols do. This is helpful because the male and female are actually mirror images of each other, so pins 1 and 2 are flipped. This also helps if you're soldering a higher density connector like a 5 or 6 pin XLR. So on a standard 3 pin, 1 is ground. Let me just tin the tip a little bit, get a little bit better conductivity of the heat. So 1 is ground, that goes to the shield of our wire. And then once you remove the iron, just hold the wire steady until the solder cools and hardens. Pin 2 is positive, so we'll use the red wire. It really doesn't matter which wires you use for positive and negative, but standards dictate that red is usually positive, so we'll use red for pin 2. And pin 3 is negative, so we'll use this clear one for negative. Once that's done, we'll just remove the connector and we'll move on to the male connector. I moved you around and zoomed you in even closer so you can see what solder looks like when it melts. As you apply heat, you can see the shininess of the solder changes. I'll let it cool down and I'll show that again. It's kind of a dull shine right now, and then when it heats up it gets very shiny. That's how you know it's melted. Let's bring the negative in here, and that's what it should look like when the solder flows properly into the copper. It helps that we tin the wire before. It helps that solder flow better and make a strong joint. Now all that's left is to assemble your connectors. We have the female shell on this end. The insert goes in, and then the strain relief. The strain relief in this connector works by grabbing the cable so that if you tug on the wire, it won't actually pull the solder joint, it'll just pull the cable itself. And there you have it, a completed 5-foot 3-pin XLR cable.